Hello everyone. Welcome to part 4 of my probability distribution video series. So in this video, we are going to talk about the student's t-distribution. Now, if you haven't watched my video on normal distribution, I highly recommend you to watch it, and the link will be given in the description because student's t-distribution is just a generalized version of the normal distribution. So let's dive in. So first of all, student's t-distribution is only applicable when the sample size is small. Because when your sample size is small, then the mean and the variance calculated from that sample, from that set of samples, does not represent the real population mean and variance. For example, this is a normal distribution curve of Indian male heights. As you can see, most of the male heights revolve around 70 inches. That means most Indian adult males have around 70 inches height. And there are some rare individuals with very, there are some rare individuals who are tall, who are very tall. And also there are some rare individuals who are very short. Now, suppose we randomly pick only 5 sample from this distribution. So this is just random sampling. So if we randomly sample 5 samples, they can fall in these ranges. So they can be these 5 red dots, all right? So since it is only 5 samples, the heights are very much skewed towards the right side of the distribution. Now, obviously, if you would take maybe 50 samples, this wouldn't be the case. Most of the random samples would come from the middle, a few would come from the left, and a few would come from the right. But since we only have 5 samples, that is why it is being skewed. So obviously, if we calculate the mean and standard deviation of these 5 samples, they will not represent the actual population mean and standard deviation. That is where student's t-distribution come to the rescue. So as we saw in the previous example, suppose you do have the height of 5 Indian males. In that case, there is a concept called degree of freedom, or DF in short, for the t-distribution, and it is going to be n minus 1. That means 5 minus 1 equal to 4. So I have actually drawn some curves here with different degrees of freedom. For example, when degrees of freedom equal to 20, that means there are 21 samples here. Standard normal distribution is actually the black one, which you can see here. So if you pay attention, you can see that when there are very few samples, say only 4 samples with 3 degrees of freedom, the tail is very fat. It's a very fat tail, right? It's not going down very easily. And also the mode is very short. The mean density isn't really that tall. As we keep increasing the sample number and in turn the degrees of freedom, you can see that the green curve right here is very much close to the normal distribution, right? So this means like the tail becoming less and less fat. What actually it means is your variance is actually decreasing. Now, if you want to plot a t-distribution or if you want to construct a t-distribution, your df should be bigger than 2. At least more than 3 samples should be there. Otherwise, you will have some difficulty with variance because then there will be a lot of variance. Now, when your sample size is above 30, then t-distribution will look very much like normal distribution curve. And so you can just replace your t-distribution with a normal distribution probability distribution function. So, as we saw in the previous video, there is a term called standardization of normal distribution, where the mean and standard deviation are transformed to 0 and 1 respectively. There is a similar idea in the t-distribution. We can get the t-score using this similar formula. Here, x bar and s, that means the mean and standard deviation, are calculated from the very few samples that we have. So they are obviously not the real population mean and standard deviation. So if you calculate these for all of your samples, if you, for example, here you had 5 Indian males, you can get the T1, T2, T3, T4, T5 for these 5 males. Then you have basically transformed your curve or distribution to the standardized T distribution. So how does the probability density function look like for the T distribution? So suppose you haven't calculated the T score. You just have the random variables x which are the actual heights of the Indian males. And obviously, you have the mean standard deviation and the degree of freedom. So in that case, this is how the PDF looks like. It's quite hideous, I know that. So this is the gamma function. So those of you who don't know gamma function, is simply factorial of floating point number. So as you can see, the degree of freedom plus 1 divided by 2 can be a floating point number. And so if you want to get the factorial of the floating point number, you can use the gamma function. So if you calculate the t-score and if you then modify this particular PDF, it will look something like this. So it is, I think, now much more simplified. And you can get the expected value and variance of this particular PDF. So for getting the expected value, you just integrate it from minus infinity to infinity. So this is something we have seen many times before in this series. And if you do the integration, you are going to get 0. That means the mean is 0 basically. It has 0 mean. So unlike the normal distribution, the variance is not 1 after the t-score calculation. Rather, the variance is degree of freedom divided by degree of freedom minus 2. That is the variance. So next, let's talk about the t-table and the cumulative distribution function calculation. So the t-table of the t-distribution is very different from the z-table of normal distribution. For example, let's see what 2.920 here means. What 2.920 means is that probability of the t-score being greater than or equal to this particular value is equal to 0.05. So 0.05 is actually the probability to the right side. And in the first column, we can also see what is the degree of freedom for this case. So if we increase the degree of freedom to 5, so the same integration result will become 2.015. So the integration result can change based on the degree of freedom. This is just a snapshot of a t-table. Now, as I was telling you about this value 2.920, we can also visualize it. So if we visualize it, this is the area, and the 0.05 is this area basically. If you integrate and if you calculate the area, the red area, it will be 0.05 and it is above 2.920. Okay, now there are two ways to get probability value for a range of x values from t distribution. So the first thing you need to do is obviously you need to do the t-score transformation, as I showed you before. Then you can do a simple integration. So suppose you want to get probability of t greater less than or equal to 1.5. That means whether your normalized heights are within 1.5. And then you can use this formula. You can integrate from minus infinity to 1.5 the t distribution PDF, or you can use the t-table. For example, if we want to get the probability of t less than or equal to 2.920, we can simply get this probability from here, which is 0.05, and we can minus it from 1. So it will be 0.95. But here is the issue. Suppose we want to get the probability of t greater than or equal to maybe 5. Is there any 5 in this table? There is not. So actually this t-table is not for CDF calculation. Rather, it is for significance calculation. Now, there is a thing called a t-test. So we are going to talk about this in another series, which is a series on significance analysis or statistical significance analysis. So we are going to talk about that on that term or on that in that series. So we are going to skip it for now. So just for your understanding, the t-table is not really for CDF calculation. I mean, you can use it for some cases, but it is mainly for the significance analysis. Okay. So thanks everyone. If you like the video, feel free to like and subscribe and share. And there's a link in the description of the video. You can donate to our channel through that link. Thank you very much.